Hello, my name is Kukunda Stacy. A good evening to you. And 1A, genetic algorithms are optimization techniques inspired by natural selection that evolve a population of candidate solutions over generations. They maintain a population of possible solutions and apply generic operations such as selection, crossover, and mutation to evolve solution towards a global optimum. For 1B, simulated annealing improvements made within the reasonable AI perspective include controlled exploration and fairness in solution space. For controlled exploration, we add ethical constraints to prevent the algorithm from exploring unsafe or unethical areas, such as restricting high-risk solutions in financial optimization. Then, for fairness in solution space, we ensure that equal exploration across different areas, particularly in socially sensitive domains like healthcare, to prevent bias towards any group. Then improvements made in the explainable AI within the simulated annealing, explaining the annealing process, which includes clarifying why the algorithm accepts worse solutions at certain steps to escape local optima. Then there is visual temperature and solution changes. This includes making the cooling schedule and solution quality shifts more understandable through visualizations. Then for genetic algorithms, improvements made in the explainable AI, there is explaining the annealing process and visualizing temperature and solution changes. For explaining the annealing process, we clarify why the algorithm accepts worse solutions at certain steps to escape local optimum. Then for visualizing temperature and solution changes, it includes making the cooling schedule and solution quality shifts from more understandable through visualizations. Then we go to genetic algorithms. Within the explainable AI, the improvements made include interpreting fitness scores and explaining crossover and mutation, then post hoc explanations. For post hoc explanations, offering explanations after a solution is found, detailing how the fitness function, crossover, and the mutation influenced the outcome. Then explaining the crossover and mutation, visualizing how genetic material is combined or mutated to create new solutions, making the evolution process clearer. Then for the responsible AI part, there's ethical fitness function. Ethical fitness function, we incorporate fairness or safety metrics directly into the fitness function, such as the ensuring equitable access in healthcare resource allocation. Then safety checks. This is where we ensure that solutions meet ethical and safety standards, especially in engineering designs. A population, in this case, would be a group of potential solutions, like the possible outcomes of a certain situation that you're going through, often represented as binary strings or other formats. Then chromosome. A chromosome is a string of data that represents a potential solution to the problem. Then the genes. Each gene is a single unit of data within the chromosome, representing one part of the solution. Then for the fitness function, it evaluates how well each individual solves the problem. The higher fitness values indicate better solutions. Then for the selection, parents are chosen based on fitness. Common methods include fitness, proportionate selection, and tournament selection. Then for the crossover, combines genetic material from two parents to produce offspring, typically using a random crossover point. Then for the mutation introduces random changes to offspring, promoting diversity and preventing stagnation in the population. Then a case scenario would be optimizing public resource allocation. A city needs to allocate its budget for public services like healthcare, education, the construction, and everything. Then the best performing allocations are selected for reproduction and crossover, and mutation are applied to explore new resource distribution patterns. For 3A, it's about adversarial machine learning. Adversarial machine learning involves strategies to deceive the machine learning models by making subtle input, like small changes to the information given to the machine learning model. And the two main attacks are white box attacks and black box attacks. White box attacks mainly affect the internal part, where the attacker knows the model's architecture and parameters, enabling sophisticated adversarial examples. Then the black box attacks, the attacker lacks the intel on the internal knowledge, but learns to generate adversarial examples through observing the model's outputs. The adversarial machine learning poses significant risks in areas like image recognition, where small changes can cause miscalculations and so on. Then for 3B, it's telling us to show the difference between adversarial search and adversarial machine learning. For adversarial machine learning, the attackers try to mislead the models with manipulated inputs. Both fields focus on dealing with adversaries. Adversaries are like limitations, but while adversarial search finds optimal moves in the games, adversarial machine learning focuses on defending models from attacks. Both involve strategic planning and strategic reasoning. For 2A, we are describing adversarial search, which involves searching in environments where multiple agents compete with each other while aiming at minimizing the success of the other. And then this can be commonly used during chess, when a chess game is going on and the other person is trying to minimize the success of the other. Then the applications in the real world, within security systems, adversarial search can be used in cybersecurity, where you minimize the attacks from the other by applying things like firewalls and antiviruses. Then for financial markets, adversarial search can be used while trying to think about the strategies that the other opponent is trying to use into the competitors, and you maximize the impact. Then for 2B, minimax and expectimax algorithms. They are different in such a way that the minimax algorithm is used in a zero-sum games, where one player aims to maximize utility while the other tries to minimize it. The max assumes min will respond optimally, and the game tree is explored to terminal states where utility values are assigned. The mini-max value over state represents the utility for max if both players will probably pay optimally. For example, in the chess game, it comes up in the chess game again, where the opponent is trying to maximize and the other is trying to minimize. The worst case scenario, considering the means optimum response. Then for the expecting minimax, algorithm is a variant used in games involving chance, like the dice games. You roll a dice and it's either you roll a 1, a 2, or a 3, depending on the dice. It can be a 6 dice, it can be a 4 dice kind of thing, and the chances are unlimited. They are very integrated. It integrates chance nodes, calculating the expected utility by averaging over all possible outcomes rather than simply maximizing and minimizing. And then for 2C, alpha and beta pruning. Alpha and beta pruning is an optimization technique for the minimax algorithm. That reduces the number of nodes evaluated in a search tree by cutting off the branches that won't influence the final decision. It works by 2 values, the alpha value and the beta value. The alpha value is the best option found so far for the maximum value. Then the beta is the best option for finding the mean value, the minimum value. For example, if Max finds a move that guarantees a score of at least 3, and the means move results in a score of 2, further exploration of that branch is unnecessary, since mean would never choose that option. The main purpose for alpha beta pruning is to improve the efficiency of the minimax algorithm by speeding up the search process without affecting the final outcome. Then for 3A, it's about adversarial machine learning. Adversarial machine learning involves strategies to deceive machine learning models by making subtle input modifications that lead to incorrect prediction. It's like giving a test to a fellow workmate, and you ask them if is my name Stacy or is my name Kukunda. Either of the okay.